Alright, let's look at the electromagnetic spectrum, and these are pretty much all the known frequencies and wavelengths of light that we use in everyday activities. Now down here we've got the longer wavelength light, and as I said earlier, we know that wavelength and frequency are inversely related. So if we're talking about a long wavelength, we're talking about a very small frequency. So if we've got a wavelength of 100 meters, that's 10 squared, then we're talking about a frequency that would have, which would be 10 to the sixth, or 1 million hertz. And what we're looking at there is is radio waves. And if you look at a very old car radio dial, you'll notice that it comes out in the range of about 500 to 1,000 kilohertz, and 1,000 kilohertz is about a million hertz. That's 1,000 hertz. That's a million hertz. So you can see how that works out. FM radio is in megahertz, and you'll note that an FM radio dial goes from about 88 megahertz up to 108 megahertz. So you can see that's going to be about 10 to the 8th. So that's 100 times 10 to the 6th, or 10 to the 8th hertz. So we're talking about there about 10 meters on the wavelength there for the FM radio. Then you see we've got microwaves, and those have typically about half meter wavelengths. And what's important about those is that those are the wavelengths that water will absorb and rotate, and that's what causes food to heat up, is the microwaves causing the water in the food to rotate and produce heat. Now we get our baseball, which is about 10 centimeters, and that's going to that would have that would be a frequency. 10 centimeters would be about 10 to the 10th hertz. Now we get up here and we're looking at infrared. Infrared is like heat radiation, and you see we're getting to much smaller wavelengths and much higher frequencies down here. And we get to the visible frequencies, which are going to be around 10 to the 15 hertz, and we're talking about much smaller wavelengths, about 10 to the negative 6, 10 to the negative 7 meters for visible light. Then we get into much higher frequency light, and high frequency light is very high energy light. We're talking about X-rays and gamma rays, and we know what kind of damage that those can do. Because the light is of such high frequency, therefore it's of such high energy, it can easily knock electrons off molecules and off DNA. So we know that these kinds of things, especially hard X-rays and gamma rays, are cancer causing because they have the ability to knock electrons off DNA. So we're talking about very small wavelength light here, but very high energy and very high frequency light. And you can see the relationships here. The long wavelength, we've got a long wavelength going to short wavelength. So we get low frequency to high frequency. And as you can see, that as the frequency increases, so does the energy increase as well. And we'll look at the formula that relates energy to frequency in a little bit.